Hello everyone at Digital Realty and welcome to today's webinar titled 5G Implications, New Network Architectures Bring Compute Power and Disruption to the Edge. A couple of things before we get started. As you have questions during the presentation, please put them or type them into the Q&A box and we will get to those at the conclusion of the presentation. I'd also like to take just 1 second here to thank Stacy Lawson for help getting all of you here today and being a big help in creating TBR awareness over there at Digital Realty. Very appreciated. So I think we'll get started, and I'll hand it over to Jeff Willicott.
Oh, okay. Thanks. Thank you, Sun K. Hi, this is Jeff Willicott. As mentioned, the first thing you'll see were the presenters. Joining us today, the real man of the hour will be Chris Antlitz, given as we look through what Stacy had sent over as the core questions to caucus as to what would be an appropriate subject matter to present to you folks. We felt really the enabling and sort of central point that needs to be calibrated is the implications of what 5G can do to all the other component parts that we know are evolving and have been sort of shifting, if you will, for the last decade since sort of infrastructure as a service came into being 10 or more years ago, that's where we wanted to focus it. So Chris will be able to articulate that. We have that really at the end. Ezra Gottheil and I have worked together on a couple of slides in terms of edge to core to cloud in terms of the implications that are going on with that subject matter. Ezra and I will take you through that. And Alan Kranz is here. He has been the lead of our cloud practice for a number of years. And we have him here more in the event there's a question that is beyond our depth and scope. Alan will be able to chime in and provide you with the insights from that body of work. So if we can move to the next slide, which will give you the basics. What we'll do is take a look at what we consider edge computing in its current state, what we believe the future state will look like, and then get into the implications around 5G as one of the principal enabling layers that's got to gain commercial adoption for that future state to materialize. So if you can move to the next slide. So this construct, if you take a look lower left, we're not making a big distinction between data center and cloud. There's a lot of taxonomy definitions between a private cloud, a hosted cloud, a managed private cloud, or a public cloud. But the bottom line is, where is the compute power, the large compute power being located? And that really is in either a data center or in some kind of a cloud construct. On the far right, what you have is just the explosion of the number of different devices that are there or are available that either can then be aggregated and virtualized into a fog or a swarm compute environment. That's another threat that's coming into these co-located data centers, is how much compute you can virtualize from the edge. That's really not here yet, but it's one of the threats to that whole area that we're defining as the edge, which as we're depicting it here, it's the idea of a gateway or the access point for that data to get it into whatever kind of a pipe you want to call it, either at the local server or to be fired back into the data center or the cloud. That is, in a general sense, how we're taking a look at it. And the challenge is, that's what the red arrows at the top of this are intended to imply, are the business rules versus workforce and intelligent augmentation. On the one hand, you hear about the empowerment of the end user and the ability to access whatever they want, bring their own device, write in any code they want, et cetera, et cetera. And then on the other side is the data governance for, or the business rules of who has access to what, identity management and the privacy. It's the business rule side is rising to a board level decision now. The joke that we use internally to discuss this is nobody on a board of directors wants to have a Facebook moment and have to go testify before Congress because of a privacy breach and so on and so forth. So those are the points that are kind of coming at each other. in terms
Jeff,
of this current, yeah?
Jeff, this is Ezra.
Ezra.
Just let me say that the current interest in the edge has been driven by the rise of IoT and the fact that IoT sensors can generate literally limitless amounts of data, depending on the sampling rate and the precision of the measurements and things like that. So a lot of solution design now is focused on how much data to use immediately, how much data to store indefinitely, and then where to put the data and where to store it. And that has generated a new, more sophisticated architecture where original IoT was kind of a client server. There were devices and there was the cloud. And now there are several layers that are being interposed to gain more efficiency out of the data that are captured, and also to deal with issues of latency with these IoT applications. When the IoT applications are actually doing something as well as capturing data, there's a need to get the information processed quickly, and that has led to the growth of computation nearer the devices, or what we call the edge. It's interesting to note that we call it the edge, businesses call it where business is actually happening. Using the term edge is a very IT-centric way of looking at it. Okay, back to you, Jeff.
Not a problem. That is, as I said, Ezra and I come with it with different perspectives, and it's good to keep me honest. As you're looking at the point of view components there, what we were looking at is, well, where's it going to be and why? To Ezra's point, there's a lot of the IoT data capture. Is there a need or is there a concern? The key points that we see there is the cost implications. It's power, it's the technical debt, it's the cultural affinity, the latency and the real-time decision-making is one of those keys. One of the emerging use cases where they say they'll need compute at the edge is for, say, inference for surveillance cameras in airports, where you need that real-time analytics, and the latency of shooting it across the pipe is going to be too cost prohibitive, and likewise not give you the real-time decision-making or machine-level learning that's going to be required. Now, the other thing that's going on is really this sort of endpoint of Moore's Law economics on the scale and power that we know, in terms of the board-level innovations that are going on for, some cases, some people call it accelerated computing or augmented computing, but the explosion of the TPUs, FPGAs, and GPUs that are springing up largely for what I'll call distributed computing on the board for these large analytics processing types of application layers, and how many of those are going to need to be at the edge, or how many of these can still be in the sort of the cloud instance for a large analytics database, a Watson kind of cognitive approach. So with all this, on the last piece there is the IT law business interactions around the operational technology are going to require a lot of management changes in order to succeed. That comes through both in terms of advisory services on how to change the business rules, as well as the IT layer. And before I jump on that, go to the next slide. Is there anything else you'd like to add here?
No, I think that covers it quite well. Thank you.
Okay, yeah. Ezra's on mute. He's remote, so there may be a lag as he and I throw it back and forth, but we're only here for another slide here. And what we've been looking to show here is the idea that the data center and cloud instances, we know they're growing. Amazon is growing at about 50% quarter or year over year on the quarter. IBM, while they're somewhat criticized for it, are still growing at about 20% year over year on the cloud growth. So we know those things are still burgeoning. The server side has also had a pretty big hit that we've seen in terms of these things. So the gateway server convergence is going to trigger multiple form factor solutions. That goes to the idea from a data center perspective that the kind of a commodity Intel server dominance is going to start disaggregating and fragmenting into almost purpose-built appliances. And to us, that the analogy we use is that if you're buying cable service, you're not buying the set-top box. You don't make your decision based on the set-top box. You make your decision based on the content that will come over it. And that's the same element that's going to happen with what I'll call it the endpoint devices, the small appliances that may have compute within it, or it may just be a security layer and a aggregating access point to fire it over across the network to a larger compute instance. That's where you're going to see, as we call it, the XPU, or innovations to disrupt the CPU space. There's going to be those opportunities for the sort of specialty use cases, the rise of the ODM that may threaten the Dell EMC, HPE services juggernaut. And then lastly, the fog computing aspect that comes in for gateway and server margins, just the compression. You're seeing that challenge on the device manufacturers that play sort of at the edge of it being hammered from one side from a profit perspective as Amazon raw compute becomes cheaper and cheaper, and then on the other side as fog compute becomes more and more of a reality. And with that, I'm going to pause. There was apparently a question, which was, who is primarily defining the edge IoT workload requirements, and how is this changing how edge computing is developing? Ezra, I'm going to put you on the spot in terms of the definition of the edge IoT workload requirements. Do you have a comment there?
Yeah. So right now, what the largest amount of innovation and implementation of IoT is being done at a relatively small scale. There are these corporate-wide transformational projects. Some are going forward, some are stalled, but all are long-term. But where there's enormous growth of IoT is at the departmental line of business, factory or factory line level, and the people building those things, typically operations oriented, are defining the workloads. But then when they've got a working model, then they become involved with centralized IT. And have to scale this and deal with a kind of a refactoring and a re-architecture. But the need is coming entirely out of OT. OT is, I think, more intensely oriented toward compute rather than storage. Well, we see a lot of analytics applied to streaming data. There's a lot of potential for historical data to be analyzed, but we see less of that. These are get-her-done, lower-cost projects. These are not the ambitious business transformation projects. And as such, what we're seeing more of is rapid processing and reaction to incoming data.
Okay.
I hope that answers your question.
At this point, we don't have any other questions from the audience, so what we want to do now is hand it over to Chris Antlitz to go more into the 5G implications in terms of what this all means.
Okay, great. So just to add to Ezra about the workload requirements, also the web scales play a heavy role in this market. So caching content closer to the end user, improving quality of experience. If you're an OTT or a digital native player, you have an active role specifying the workload requirements, and we're seeing a lot of activity happening within that customer segment. So we talked a little bit about high-level stuff, what's going on at the edge of the network, the interfacing between cloud environments and the edge. I'm going to make this a little bit more real, especially to the digital realty business now. So this is what we see going on and where we think this is going to go. So virtualization is coming into the network domain, and the architecture of the network is fundamentally changing. Networking and IT are converging, and we see this manifesting itself in many different ways. One example is virtualization, where you take individual network functions, maybe a router, or it could be a mobile core box, and you disaggregate the software layer from the hardware layer, and you put the virtual function into a NFVI environment, which is essentially a data center environment. So you have this architectural change in the network that's occurring, And you also have new use cases for the network that 5G is going to bring into the market eventually. It's going to take a little bit of time for these new use cases to materialize and become, to have a business case around them. But what we do see is leading operators and edge participants, let's call them that, are all vying for a piece of the pie, and they're all starting to stake claims in the edge compute market. So we're going to walk through how we see this playing out. There's two reasons why this needs to happen. One is latency, and the other is transport costs. So for latency, one of the big things that I keep hearing about on my travels is we need to shave milliseconds off of the loop, off of the data transmission loop. Right now, networks are highly centralized, so the cloud environments are highly centralized, and this is what the business model of the Equinixes and Digital Realties of the world is, where they have data centers that are in regional locations dealing with very heavy loads of data traffic, at any given point of time. What needs to happen is the compute workloads need to be distributed because the latency requirements that are going to be put on the network, that model is not fully able to meet those requirements. And the biggest reason is Shannon's law. So for those of you who aren't familiar with Shannon's law, it's a physics limitation in the speed of light and how fast you can transmit a data packet. In a world where we're talking about mission critical use cases for the network, you're talking about latencies that need to be below 10 milliseconds. If you look at light loops, the current way data centers are configured in the location, the spatial differences that they are on a geographic standpoint, they're not equipped to, because of the light limitations, to meet those strict latency requirements for 5G use cases. Therefore, the industry needs to now evolve and push the compute out further to the edge. So that's the latency side of the equation. The second piece is transport costs. So that the current model is we're going to transmit the data packets through the central cloud environments, regional data centers, right? That's how we see them. And they're going to do the processing of the information, right? The processing of the data. Well, that's fine, and that can work, especially if you have full fiber rings in there with enough density within those optical cables. But there's a cost associated with carrying that traffic. So what some companies are starting to do, like the OTT players, are caching the content closer to the end user. That not only improves the user experience, but it also deals with the carriage cost of the traffic. I'm going to answer all the questions after I go through the content. So we're just going to keep going through the content here. So that's what's happening at a high level. So let's take this a step further now. There needs to be a build out of the edge. And what does this look like? How is this going to manifest itself? So right now there is a land grab underway for securing access to prime edge locations. And we see this occurring in the States predominantly right now. Essentially what's happening is you have a variety of different players in the market, be it a telco or be it a tower company, or there are edge compute, more pure play companies out there, companies that it could be other infrastructure entities like a utility company, for example. And basically what's happening is there's an identification of sites that would have access to power, have access to the requirements that would be needed to site mini data centers as close to the endpoints as possible. There's a couple of areas where there's a lot of interest. One is at the cell site, so that can be a cell phone tower. That can also be a rooftop. Wherever you have a cluster of base stations for the access layer of the network is a viable location because that is the closest you can be to the endpoint and yet get the latency and the transport efficiencies that we're looking for in an edge compute environment. Another area that's receiving a lot of interest is how do we repurpose existing central office and head-end real estate to put a mini data center in those environments. So as you know, the telcos and the cablecos have tens of thousands of central offices across the United States, and there is a lot of that real estate is owned by those companies, or it's leased and it's under long-term contractual agreements. So they have access to that land already, and what they're doing is they're repurposing those environments and putting edge compute locations in those, so making POPs, edge compute POPs, in those existing locations. This is what the edge is going to be configured at, and it's going to be players like the telcos, the cablecos, and shared infrastructure players like American Tower, Crown Castle. Those are the companies that are going to own significant portions of the edge. This is a issue, right? Because Equinix's, the Digital Realties, the more traditional centralized cloud players in this market have predicated their models on the current way that clouds are configured. The problem is, how do those companies transition their business model to capture the edge opportunity now? So as the compute needs to get pushed further out or deeper into the network, closer to the endpoint, how do you make an economically viable model that can capture that when you don't already have access to the edge locations that are considered prime locations? This is a business conundrum that those players need to figure out. And I can also tell you that the web scales are trying to figure this out too, because either they own their own data center locations, or they have colo arrangements with the data center REITs to have that access and build those clouds globally. Now the next natural extension, the next natural evolution of that business model is, okay, now we need to push more of that compute deeper into the edge. So this implicates a lot of players. It's going to shift some of the, who are the players in this market, who has access to what assets that are considered desirable here. There's going to be a lot of attrition in the market. It's going to be a wild west for the edge. This is going to take years to play out, but we're already starting to see this happening, and I gave a couple of examples of that. So that was my spiel. I think we can open it up for the questions. So we're going to take the questions one by one. And I'm going to start with what % of workloads are expected to be pushed out to the edge. So that really depends. What we're going to see is a combination of computations occurring at the edge. We're going to see computations occurring in the traditional cloud environments that are more centralized in nature. Really what it comes down to is, what are your requirements? So what are your latency requirements? What are your SLA requirements? What are your data sovereignty requirements? And individual use cases for that, for those compute resources, will dictate what the configuration of workloads allocation will be. So it's going to be a mix, right? Not everything is going to move to the edge, and there's reasons for that, right? Economics being one of them, depending on what types of workloads it is, what types of requirements are baked around those workloads. It's going to be a mix of the two. And the next question is, how much power is expected to be deployed by network infrastructure players? DLRs often deploying tens or hundreds of megawatts in a market. So if you look at some of these prime locations, they already have access to power. If you look at traditional telco central office environments, those are structured to have heavy drawdown of power, and the assets are already there. The power, the utility assets are already built into those environments. So all they need to do is repurpose them and plug them into the edge compute environments that are in that same real estate environment. So from a power perspective, if you look at the prime locations, there's already quite a bit of power able to be tapped into. Where it really becomes a question is where you want to develop sites that I would say are subprime, if we can use that term, sites that are not already utilized for traditional network environments, but are going to need to be developed from the ground up, maybe a greenfield environment that might not have a power hookup readily available, or a power hookup that has the megawatt threshold that's required to support that edge compute environment. So my point is, the prime locations are going to have the power challenge already addressed. That's part of what makes them prime locations. Anywhere where you need to build a greenfield environment, that's where you're going to have some challenges with logistics here and the configurations of building these edge compute environments. So that's going to be a different story, and that's why some of the more traditional players are going to have trouble here, because they don't have access to some of those environments. One of the things we do see is partnership models, shared infrastructure models, where you have a real estate owner or a company like a tower company that has the real estate already, they already have access to those environments. What we're seeing is they might actually lease or sublease part of that real estate footprint to an edge compute provider to build the edge compute environment and deal with all the logistics required with that. And the model is they get the lease payments every month. And, you know, that is also going to be a viable model that emerges. So I see two models emerging right now. One model is the infrastructure owners own or take a very heavy-handed approach in the edge compute environments versus a more hands-off approach where they sublet some of the space that they already have under their portfolio to more traditional edge compute providers, or even the centralized cloud providers that do things like colo or, you know, could be those types of players. So there's different models emerging. I think it's going to be a mix of the two for what actually winds up happening in the market. I don't think it's going to steer more to one way or the other. It really depends on the business and their requirements, and there's a lot of variables at play here.
Well, at this point, we're sort of near the conclusion of the formalized portion of this. We wanted to leave enough time, based on the breadth of questions that we'd received from Stacy, to see if there were any other questions the audience may have that they would want to ask us. While you're pondering those, if there are any, if you can advance it a couple of slides just to give a quick look. But yeah, just leave it here. We don't need to, we're not trying to sell necessarily, but what I wanted to be able to show you with the domain areas where we have various individuals here with a certain level of expertise. I cut across it as a custom, I do a lot of custom project work, but what you've had here is some presentation from 3 of our analysts. We have about 40 on staff. So the other areas that we cover besides IoT telecom is the cloud and software piece, devices, professional services. That is clearly an area where there's a lot going on, and there's a lot of disruption and movement within services, particularly around helping the customers determine what is the best application layer or best compute instance to configure, either, you know, mapping together the components of technical debt and what they can sort of repurpose or refinance is the way we talk about it, rather than retiring technical debt, to refinance the technical debt. There's a lot going on in there. There's a data center coverage, which is looking both at the physical components or the constructs, as well as the innovations that are going on, as we said, you know, moving these things further down into purpose-built appliances. If you take the notion that the smartphone that most of us is holding in our hands has the power of about 1,000 servers from 20 years ago, you can see how edge compute and the single-threaded apps that sat in I call it a small, large enterprise data center from 20 years ago is now either a handheld device or something that can easily be glued into an area. There's a lot of implications that require a lot of services domain work, and that requires typically a lot of partnering and a lot of alliances with the different pieces of what is now the ecosystem play as we've moved from a pipeline business model to the ecosystem and network effect business models. So these are all various other assets, other resources we have at TBR that we can raise, and we do have 2 more questions, so let's take a look. Just click one on. Okay, so telcos have been selling their data center businesses. When do you see them reinvesting in the central office data centers at the new edge? Can you answer?
Yeah, they're already doing it. So AT&T's doing it, Verizon's doing it, CenturyLink's doing it. They use the term CORD, so central office re-architected as a data center. I've personally seen some of these. I've toured some of these environments, and this is exactly what they're doing, is they're building mini data centers at the edge of the network. Some of them don't talk a lot about it because it's highly strategic for their future, but I can tell you that this is absolutely happening in the States, and it's very likely happening in other markets as well, like China. I would suspect Japan. These types of builds are happening as well. Again, this is very much driven by NFV-SDN, so the virtualization, the network transformation, and that architectural transformation necessitates having data centers at the edge of the network so that you can process the VNF traffic and support your customers with a better quality of experience.
We have another question. Do you see where network service providers implement the model you mentioned but still use a digital realty as a location to effectively interconnect?
Yeah, so there's different aspects of the value chain. So there's different models that are out there. There are definitely areas where you'd see multiple players in that value chain providing the solution. It really depends on a range of variables, why a telco would choose to configure that value chain in certain ways, depending on the market, depending on what their needs are, depending on what their long-term strategy is. Yeah, absolutely. Would digital realty be a part in some of these value chains? Absolutely. It really just depends on those variables.
And that really boils down, that in some ways is that notion, as I was speaking about services, an area where we do a fair amount of work is in this opportunity assessment and partnership alliance research to determine what are the sort of prevailing or evolving partnership agreements between what had been sort of traditional siloed business entities as they're all trying to pivot into the sort of new digital business operating model, which, again, to use a rather overused quick idiom, is the shift from analog dollars to digital pennies. I mean, it's the move from the product sales to the outcome or solution sales. It's no longer just shipping the physical iron to different people to have them wire it up and write the code on top of it. It's more an ecosystem that is brought to bear with an individual in the lead, and the effort is more almost giving away that upfront piece for free to make it up on the transaction volume that can happen if they're participating in that broader ecosystem. And that in some ways is the whole hit and evaluation of the different physical constructs that are capable. And with once the network is finally virtualized, all three elements of kind of the historical elements that have driven business model evolution in our industry of compute, storage, I/O, and the network pipe that runs between them, with all of that virtualized, the different physical assets that are drawn through are more of a derived decision, with the overarching or primary decision being the quote unquote, I hate the term, but the business outcome that's requested or desired.
So I just want to get back to the telcos selling off their data centers. I want to put a distinction around what's really going on here with the telcos. The telcos sold the data center businesses because they couldn't win in colo and they couldn't win in IaaS. That market went to the web scale players and it went to the data center REITs. And the telcos couldn't find the margin and the scale there that they wanted. So they sold off those data center infrastructure assets. But if you look at the central offices and you look at the network architecture changes that are being necessitated by NFV-SDN, so the cloudification and virtualization of the network, and also the requirements for 5G use cases, which are coming. They're not here yet, but they're coming. They're building data centers in the central offices. So whereas before they might have had dedicated centers where you would have a data center environment separate from the CO, which I would say is more of a central or regional type data center configuration, which is very similar to what the web scales have. what they've done is they've sold that off because that was non-core, but they're being pushed into edge compute because of the network transformation that they are undergoing and because of the 5G use cases that are going to come from IoT type use cases of the network. And then there's a follow-up question here about covering the various 5G deployment types, how they're going to impact the edge. So it depends on what your definition of 5G is. I've seen two distinct definitions for 5G. One is it's an access layer evolution where you migrate from LTE radios to 5G radios and you get a performance boost from doing that. The second way to define 5G is it's an end-to-end architectural change to the network. We've talked about that already, right? The cloudification and the virtualization of the network is, by some people's definition, 5G. So when we look at the use cases, though, of the network and what the end users are interfacing with, how does that manifest itself? Well, let's look at the phases of 5G deployment. What we see right now is that the first phase of 5G deployment is about enhanced mobile broadband and fixed wireless access. Neither of those is particularly sexy in terms of use cases for the network, but they're incredibly important for the telcos. Because with 5G, it's significantly more efficient on a cost per bit basis compared to LTE. So essentially, all the telcos you see deploying 5G right now, they're justifying that investment because of the efficiency gains they're going to get from using the radios on the 5G spec radios versus LTE radios. So that's going to help them mitigate the data traffic growth that they're experiencing. Where the story really gets interesting is a few years from now, where we see, and we talk about this, by the way, in our 5G reporting, that we see two distinct phases for the 5G market. We're in phase one, and we see phase one extending to the early 2020s, which is what I was just talking about with the spectral efficiency gains, the cost per bit reduction that the telcos are experiencing versus LTE. Where it gets interesting from a market perspective, and particularly for a digital realty perspective, is phase two. Phase two market development is when you see new use cases, innovation occurring inside of the network, inside of the broader economy that leverages the benefits that you can derive from this new network that is enabled by 5G technology. That's where it gets interesting, and that's where edge compute is really implicated here, because when you start talking about scaled implementations of autonomous driving, when you start talking about scaled implementations of AR, VR, or whatever other manifestations there that the industry loves to talk about, the reality is we're nowhere near realizing those types of use cases at scale. And by the way, there's no business case yet for those use cases of the network. Where we see the stars starting to align is in the early 2020s to mid-2020s. That's when you're going to see huge demand for edge compute resources to support the low latency requirements for those use cases of the network. Right now, and maybe Ezra might disagree a little bit, but from my standpoint, this really gets interesting in the 2021 to 2022 timeframe. We're going to see a real market pivot in terms of the infrastructure requirements and what is being demanded in the market. Right now, it's a radio evolution talk. In a few years from now, it's going to be an edge compute build-out where you're going to need, where the use cases are actually going to economically support the build-out of those edge compute resources.
Okay, if there isn't any more questions, this would be the conclusion of our presentation. If there are other questions that you think of after the presentation, this is Sun K. I'm the Relationship Manager with Digital Realty. Please reach out to me or to Stacy Lawson, and we'll get your questions answered, or if you want to speak top of mind with the analyst, we could do that as well.
Another question there.
Oh, looks like we have another question.
So the question is, the broadcast range for 5G is significantly smaller than LTE, in which case the rollout of 5G is going to require a tripling of the amount of towers just to cover the same geographic area network covered by LTE. Is this true? Yes, it's true. So let's talk about the network topology and how that needs to change. So, okay, let's start with how networks have been traditionally configured. Most networks on the planet utilize anywhere from 6 gigahertz down to 400 megahertz. That's the spectral range that most networks globally are configured at, and that is true for 2G, 3G, 4G. 5G is different. 5G, because of the technological innovations that we have now, all of a sudden, we're able to support traditional network use cases of connectivity transmission for 6 gigahertz all the way up to 100 gigahertz. So that opens up multi-hundred megahertz blocks of new spectrum that can be utilized for 5G networks in a commercial environment. So let's talk about propagation now. When you move into millimeter wave spectrum, which is essentially 6 gigahertz all the way up to 100 gigahertz, the cell edge is dramatically reduced. So the lower the frequency band, the greater the range. So as we go up to, say, 28 gigahertz, for example, your propagation is limited at about 1,000 feet to get a good QoS, a sustained QoS. So that's a significant limitation. Contrast that with 700 megahertz, where you can get several miles in signal propagation at a sustained frequency, at a sustained transmission. So this is part of the topology of the network. First of all, LTE and 5G are going to coexist. And by 5G in this context, I'm talking about the 5G radios. So where it gets interesting is the LTE networks are going to remain. They're going to be upgraded, though, to 5G to be able to support 5G technologies like network slicing, for example, right? Where you need a 5G core, mobile core that can support that type of a network configuration. So ultimately, all of the networks will be upgraded to the 3GPP 5G spec. This is going to take years, by the way. This is not imminent, all right? I'm projecting out a decade now, and I'm looking at how slow some of the emerging markets are, and many markets are still using 2G, 3G. They're still in the process of migrating to LTE, but the end state is you're going to be using 3GPP 5G spec for radio, and you're going to be using a 5G mobile core, and because of the flexibility that platform provides, you could technically use that in spectral bands all the way up to 100 gigahertz. That's what the industry has a line of sight for. So do you need more small cells? Do you need more density in that network topology? Absolutely, you would. Most of the 5G deployments that we're going to see, especially using millimeter band spectrum, are going to be in urban environments where it's economically feasible to site small cells and extract an economic benefit from the limited propagation, from the limited cell edge range that you get from that. Now, where it also gets interesting is when we talk about carrier aggregation. For those of you who don't know carrier aggregation, this is another advancement in radio technology whereby you can take disparate spectrum bands and you can essentially glue them together, and you can increase the performance characteristics of that environment. So essentially what you could do, as an example, is you could tether together 700 megahertz with maybe 1.8 gigahertz with maybe 28 gigahertz, and you can extract significant benefits from a signal propagation standpoint, from a quality of experience standpoint, by tethering those bands together. There's spectral efficiency gains that are to be had by doing that. So radio technology has come a long way. In order to get the full benefit of the spectral efficiency, yeah, you need to use higher band spectrum, and that does necessitate the use of small cells and a higher density within the network. The other way telcos are looking to get around this is to do baseband hotels, or centralizing the BBU units within the RAN architecture. So essentially what they're trying to do is you have antennas and you centralize the intelligence of the RAN layer into BBU hotels, which is another, could also be an edge compute environment in itself, right? That's another manifestation of an edge compute environment, depending on how you define it. And basically what you have in the network is antennas that are out at the access layer. So this is another configuration, and also this is another reason why the telcos are big on this game, because as they centralize the RAN compute into centralized BBU hotels, and as they ultimately move to virtualized RAN, fully virtualized RAN, that's going to necessitate a need for compute resources to be out at the edge of the network. So all of these trends, these architectural trends, are coalescing at the same time, and they're converging at the same time. And the visual manifestation of that is that you need to have edge compute resources deeper into the network. The traditional way of architecting the cloud needs to move further out into the edge of the network to support the new requirements of the network using 5G or these new network architectures driven by the 5G architecture.
We'll wait about a minute if there's any more questions. Okay, so what I'd like to do is thank everyone for attending, and I hope this was valuable to you. There will be a survey that pops up at the conclusion once we end this presentation. It's about 6 to 7 questions. It would be great if you could answer those. And like I said, if you have other questions that come up later as you're thinking about this, you'll also get an email later that you'll have access to the recording of this, so you'll be able to hear it again if you'd like to listen. And please reach out, like I said, if you have more questions. And thank you very much for attending. Have a great day, everyone.